So, how did we all get here? For most of human history, that question was for philosophers and theologians to puzzle over. But now, for the very first time, we might actually be on the verge of a real scientific answer. And that's exactly what astrophysicist Brian Keating is getting at with this quote. It really frames this lifelong quest to solve what you could call the ultimate cold case. Think about it. A case with zero witnesses, no crime scene, and a suspect that might just be, well, nothing at all. We're talking about the birth of the universe itself. All right, so to crack this case, we got to start with the leading theory. And that whole theory kicks off with a totally revolutionary discovery, one that completely shattered this 2,000-year-old idea that the universe was just static, eternal, and unchanging. Picture this. It's the early 20th century, and astronomer Edwin Hubble notices something weird. Pretty much every galaxy he looks at is redshifted. Now, you know how an ambulance siren sounds higher as it comes towards you and lower as it drives away? That's the Doppler effect. Well, this is the same thing, but for light. The light from these galaxies was being stretched out, shifting its color toward the red part of the spectrum. And the implication? It was undeniable. They were all moving away from us. And this, right here, is the simple but brilliant logic that forms the foundation of all of modern cosmology. I mean, if everything is expanding outward, it just makes sense that if you rewind the clock, everything must have been closer together. So wind that clock back about 13.8 billion years, and what do you get? You get a single, unbelievably hot and dense point. That's the Big Bang. And if that really happened, there's got to be an echo, right? A smoking gun from that very moment of creation. So, a team of scientists led by Brian Keating set out on this incredible mission to find that echo. They went to literally the most remote place on Earth, the South Pole, where the air is so dry and stable it won't interfere with their instruments. And they built a special telescope. The goal? To capture what they called the first baby picture of the universe, this faint, ancient pattern of microwave light left over from the dawn of time itself. Okay, so after years of just grueling work in the absolute harshest conditions you can imagine, they finally got their data. And they made an announcement that sent shockwaves through the entire scientific world. I mean, they thought they'd done it. They believed they had seen the actual birth pangs of the universe, the very signal they've been hunting for all this time. We're talking a Nobel Prize-worthy discovery. The headlines were huge. But that celebration, well, it was not going to last. And here's the twist. The gut punch, really. What they thought was this incredible ancient echo from the Big Bang was actually something way, way closer to home. It was cosmic dust. Just trillions of tons of dust floating around right here in our own Milky Way galaxy. And this dust, when it gets heated up by starlight, gives off microwave radiation that, by some cruel twist of cosmic fate, looked exactly like the signal they were looking for. It was the ultimate red herring. And just like that, the dream evaporated. The team had to retract their monumental discovery. It was an incredibly painful, very public moment that was just a devastating professional and personal low for everyone involved. The case of our cosmic origin was suddenly cold again. But you know what? That's not where the story ends. Not even close. Because in science, failure is often just a signpost pointing you in a new direction. A dead end doesn't mean the investigation is over. And out of the ashes of this crushing defeat, a new and way more ambitious project was about to be born. This is where a new character enters the story. The legendary mathematician and philanthropist Jim Simons. He still believed in the mission, and he backed Keating's new dream team with, get this, $200 million to build a new observatory and finish the job. So now we head to the Atacama Desert in Chile, one of the highest and driest places on the planet. This is home to the Simons Observatory. With much more advanced detectors and multiple telescopes, it's specifically designed to tell the difference between that tricky cosmic dust and the real signal from the dawn of time. And right now, as we speak, it is collecting what Keating calls exquisite new data. This is humanity's best hope yet for finally cracking this cosmic case. So let's fast forward. Let's say they do it. They succeed. What happens then? What does it all mean if we finally get that hard data, that definitive baby picture of how our universe began? Well, the answer, it's not nearly as simple as you might think. And this is the great paradox of the whole thing. The exact same data, proof of a single moment of creation, is going to be used to argue two completely opposite conclusions. On one hand, theologians might look at it and say, see, a singular creation event. let there be light, it's proof of a divine creator. And at the same time, some atheists might look at the very same data and say it's just a quantum fluctuation, a random blip, a universe that came from nothing all by itself, proving there's no need for a creator at all. So the crucial point here is that this incredible scientific discovery, it's not going to end the debate. It's going to ignite it like never before. Science is this absolutely amazing tool for telling us the how of the universe. But that search for the why, well, that will always be a deeply, deeply human journey. You see, the pursuit of knowledge can take us to the farthest reaches of the globe and to the very edge of time itself. It can show us the how, but the search for meaning, the search for why, well, that's a journey each and every one of us has to take for ourselves.